In this video, we're going to be talking about composite functions. So a composite function is written as such. So given functions f and g, composite function would be f of g, and that means f of g of x. So some key things: this open dot here is not multiplication. So that is the number one thing that gets mistaken for composition. This is not function multiplication. The open dot means composition. And f of g means that you are putting function g into function f. So this second function is always going into the first. So the first thing we're going to talk about is evaluating function composition. So this first example says f of g of 3. That means f of g of 3. Essentially, we need to find g of 3 first, because that is what we're going to plug into f. So first we have to find g of 3. We know how to do that. We plug in 3 anywhere we see an x in function g. So replacing x with 3, and then following order of operations. So 2 times 3 is 6, and 6 plus 1 is 7. Now that has to go into function f. So this answer has to go into function f. So essentially we are working inside out. You have to find this piece of information first, and then you plug that into that function. So now plugging in 7 into function f. So over here in function f, replacing x with 7, and 7 squared is 49. So f of g of 3 is 49. Same thing in this next example down here. It says g of f of 3. So notice it's very similar, but the order has changed, and we'll see that the order matters here. So first we have to evaluate g of f of 3. So we need to know f of 3 first. So again, working inside, and then that solution will go into g. So f of 3, replacing x with 3, and 3 squared is 9. And now that solution will go into function g. Replacing x with 9 in function g, and following order of operations, 2 times 9 is 18, 18 plus 1 is 19. So g of f of 3 is 19. Go ahead and try the 2 on the right hand side. Okay, looking at this example on the right, we're given that f of x equals 4x and g of x equals x squared plus 1. And we want to find the composition of f of g of negative 2. Again, that means f of g of negative 2. So we need to find g of negative 2 first. Again, we're working inside out. So g of negative 2, we're going to function g, and we're going to plug in negative 2 for x. Negative 2 squared is 4, and 4 plus 1 is 5. Now that solution is going into function f. So f of 5. So going over to f, that's 4 times, replacing x with 5. And we get 20. So f of g of negative 2 is 20. In part B, same idea, same functions, but now we're finding g of f of 4. So f of 4 first. Again, this is not multiplication. replacing x with 4. 4 times 4 is 16. Now that is going to go into function g. So g of 16. So this solution is now going into g. And the order matters here. So g of 16, I'm going to replace x with 16. And 16 squared is 256. Plus 1 would be 257. So g of f of 4 is 257. And notice that when we did f of g of 3, we got 49, and g of f of 3, so same input, we got out two different outputs. One was 49 and one was 19. So the order makes a big difference. So you have to pay attention to the order. Work inside out. Now, those were evaluating a composition, but what if we just want the general equation here? So this example here on the left says f of g of x. Again, we are putting in g of x into f, but now we don't have a value of x, we're just using x. So replacing g of x with what it equals, g of x is 2x plus 1. So g of x equals 2x plus 1. That is what it equals. And I have to plug that into, so this is going into f. Function f was x squared. So replacing x with this entire piece. So x is now 2x plus 1, and it was x squared. So that whole quantity is being squared. Now, you cannot distribute across that sum. You need to either box or FOIL, because we have two terms here. So I'll just do the shortcut for us, but you can check it by boxing or foiling. 2x times 2x is 4x squared. Multiply these two together. 2x times 1 is 2x, and double it. That would be 4x. And square the last term. 1 times 1 is 1. And so f of g of x is 4x squared plus 4x plus 1. We can't do anything else with that because we don't have a value of x to input. That's as far as you can go. You should simplify and collect like terms, but that's as far as we're going to be able to go with that. And here, now we have g of f of x. So now we're putting f of x into g. So g of f of x, and f of x equaled x squared. So now we're going to replace x squared into our function g, and g was 2x plus 1. So we replace x with x squared. So we're plugging that in. So x squared is going in for x. Everything else stays the same. The 2, the 1, everything else stays the same. And so g of f of x is just 2 times x squared plus 1. There's no like terms. There's nothing to multiply out. That's as far as we can go. Sometimes I see students try to multiply it by x. This does not mean multiply by x. This is composition. So the open dot means g of f, and of x. This is the input. So it's not times x. It's saying the input is x itself. Go ahead and try these two on the right and pay attention to the letters. This is not a mistake. Try it. Alright, so f of g of x. So that means that we are putting g of x into f. So f of g of x. And g of x is x squared plus 1. So g of x equals x squared plus 1. That means this is our x. That's what we're inputting into f. And f is 4 times x. So 4, and instead of x, we put in x squared plus 1. That means we could distribute and get f of g of x is 4x squared plus 4. All right, next one, f of x. That means we are putting f into function f. And function f is 4x. And we're putting that back into itself. So it'll be 4 times, and instead of x, we're putting this in for x. And we get f of x is just 16x. So function composition of itself. All right, so there you go. So work inside out, plug in the inside function into the outside function. If it has a value, you need to evaluate it using order of operations.